Welcome to The Explainer. We're diving straight into a massive, honestly pretty thrilling transformation happening right now in the global AI infrastructure stack. We are actively moving away from the traditional centralized tech giants and rapidly shifting toward a fully decentralized future. And this new world, it's built on three core pillars: compute, fiber, and trust. Okay, let's dive into this. Picture this quote from a recent thought piece by Entree Capital. The year 2140, humanity is fully connected through a decentralized network of AI nodes called TWIS, the World Intelligence System. Now, you might be thinking that sounds like pure, distant science fiction, right? Well, it's actually rapidly becoming our reality today. We are literally building the foundation of this global intelligence network as we speak. So, here is our roadmap for the day. First, the global AI supercomputer. Second, the physical bottleneck of low latency. Third, how we actually go about trusting untrusted AI networks. Fourth, a really cool mathematical breakthrough in verifiable computing called range arithmetic. And finally, we'll tie it all together in the new intelligence layer. Let's kick things off with Section 1, the global AI supercomputer. We all know global compute demand is absolutely exploding right now, and that is driven almost entirely by artificial intelligence. But what's fascinating is how this immense infrastructure challenge is being solved outside the walls of your traditional data centers. And this brilliantly illustrates the shift we're seeing. We're moving away from the old paradigm, think proof-of-work systems like Bitcoin, where miners burn through massive amounts of energy purely to secure the network without producing any tangible output beyond cryptographic assurance. Instead, we have this new paradigm of decentralized AI. We are taking idle, underutilized compute capacity from all over the world, everything from high-end gaming rigs to local servers, and aggregating it into a distributed engine built specifically for machine learning. And you know, there are major players already making moves here. Take Aether, for example. They're repurposing idle GPUs to create a distributed market for affordable AI and gaming compute, which is a total game changer for startups and researchers. Then you've got IO.net, who are aggregating underused GPU clusters into a high-performance network that's purpose-built for the most demanding AI workloads out there. And consider CoreWeave. They actually started as a crypto mining company. Now they've completely pivoted into a leading AI-specialized GPU cloud provider, and they even recently filed for an IPO. What we are witnessing is compute rapidly becoming a new global commodity. It's being traded and consumed just like energy or raw materials. Which brings us to Section 2, the need for low latency. Look, it's one thing to have theoretical access to a vast global pool of GPUs, but the physical reality is that data has to actually travel, and regional connectivity is quickly becoming the physical bottleneck of this whole decentralized operation. When you are dealing with decentralized AI workloads, milliseconds, honestly even microseconds, make or break performance. This is exactly why global telecom carriers often fall short compared to regional fiber providers. Global carriers are focused on wide geographic coverage, but their local networks can actually be pretty restrictive. Regional providers, though, they have extensive, incredibly dense local fiber networks. They are quite literally built from the ground up with low latency in mind, utilizing direct, shorter physical routes. Plus, they offer the kind of flexible custom network designs that enterprises need to adapt quickly. In this decentralized world, low latency isn't just a nice-to-have, it's the new uptime. Let's ground this physical reality with a real-world example from healthcare, courtesy of LightPath. Imagine a decentralized healthcare network. Step 1. You have decentralized imaging centers generating massive, high-resolution MRI files. Step 2. Regional fiber steps in to provide the high-speed, secure, HIPAA-compliant transport of those massive files with virtually zero delay, which then allows for Step 3. Specialists at remote hubs can review those images and deliver real-time diagnoses. Without that ultra-fast, low-latency regional fiber, the entire decentralized hybrid cloud model just completely falls apart. Moving on to Section 3, trusting untrusted AI networks. So we solved the compute capacity by aggregating GPUs, and we've solved the physical data routing with regional fiber, but now we hit the ultimate digital bottleneck. If we are running critical AI models on random GPUs owned by absolute strangers halfway across the world, how on earth do we establish trust? Think about it. How do we verify outsourced computations without simply re-executing them? Because if you outsource a heavy machine learning task to a decentralized node, and then you have to run that exact same heavy math on your own machine just to check their work, you've completely defeated the purpose. Re-executing is prohibitively expensive. We desperately need a way to prove the math was done right without actually doing the heavy lifting ourselves. Now, what's really interesting about this dynamic is the standoff between two key players in verifiable computing. First, you have the verifier. Maybe that's a lightweight client or just a simple smartphone app. Then you have the untrusted prover. This is the remote server or anonymous GPU node that we don't necessarily trust. Honestly, it could even be a malicious hacker. We have to treat the prover as adversarial from the jump. The verifier needs an ironclad mathematical guarantee that the untrusted prover actually ran the AI model correctly, didn't tamper with the results, and didn't take any lazy computational shortcuts. The general setup for interactive verifiable computing works like this. The verifier sends the model and the input data over to the untrusted prover. The prover runs the heavy neural network and sends back a claimed result. But here is where the magic happens. The verifier then fires off a series of random cryptographic challenges. By correctly answering these specific randomized challenges over a few rounds, the prover essentially generates a mathematical proof of correctness. If the prover tries to fake the result, there's no way they'll be able to answer those random challenges correctly, and the verifier will definitively reject the computation. It's like an impossibly hard pop quiz that you can only pass if you actually did the work. Let's dig into the math in Section 4, Verifiable Computing and Range Arithmetic. Here is where the science fiction turns into incredibly clever hard math. Researchers at Sharif University and the University of Minnesota have proposed a brilliant new framework to solve a massive headache. The problem is that standard verifiable computing operates over something called finite fields. Now, finite fields are great for basic addition and multiplication, but AI neural networks? They rely heavily on fixed-point arithmetic, rounding off decimals to save memory, and nonlinear activations, specifically the crucial ReLU function, which just outputs 0 if a number is negative. Traditional verification methods struggle immensely with this AI-specific math because they have to rely on complex Boolean encodings, high-degree polynomials, or these massive lookup tables. It makes the verification process agonizingly slow and resource-heavy. So the crucial point here is how this new method compares to the old guard. Compared to older methods like Mystique or integer scaling, this new range arithmetic method maintains an incredibly low communication overhead. It's represented mathematically as O of log n, which is basically a fancy way of saying it requires very little data transfer back and forth between the prover and the verifier. It also keeps the prover and verifier computational complexities well in check, matching the current state of the art. But most importantly, and this is huge, it is the only highly efficient method that successfully supports verifying the ReLU activation function without crushing overhead. I know it's easy to get lost in the equations, but remember that this abstract math is actually mapping out the physical layers of a deep neural network. The researchers figured out a way to fuse some check protocols for the arithmetic with range proofs for the rounding and activations. This means they can verify the matrix multiplication of one layer, efficiently round the numbers, apply the nonlinear ReLU activation, and pass it right to the next layer, all while maintaining absolute cryptographic proof that the untrusted node isn't cheating. It's the key that enables totally trustless, decentralized machine learning inference. Let's move on and see how this builds upon existing technologies in terms of raw performance, because the results are pretty striking. Across the board, whether we're talking prover time, verifier time, or the data communication cost, as the number of neural network layers increases, range arithmetic drastically reduces the computational overhead. The previous state-of-the-art methods just skyrocket in cost, while this new method scales beautifully, making decentralized AI a practical, everyday reality. Wrapping it all up with Section 5, the new intelligence layer. We've looked at all the individual, specialized pieces today, and now it's time to put the puzzle together. When you combine global decentralized compute capacity, low-latency regional fiber connectivity, and the cryptographic breakthroughs of verifiable math, you create a completely new foundational infrastructure stack. Which leaves us with this ultimate provocative question to ponder. If compute is rapidly becoming as foundational to human progress as energy or raw materials, is your infrastructure ready to plug into this new decentralized intelligence layer? The centralized cloud monopolies are actively being challenged by a global network of idle GPUs, connected by lightning-fast regional fiber and secured by unbreakable verifiable math. The future of AI isn't locked in a massive data center somewhere. It's decentralized, it's verifiable, and it is happening right now. Thanks so much for joining me on this explainer, and I'll catch you next time.